Hello and welcome to a session on real-time systems. This is Dr. Anita Pujar, Professor in Computer Science and Engineering Department at Walchand Institute of Technology, Solapur. At the end of this session, learners will be able to know about what are real-time systems and their timing requirements. They will also come to know about the types of real-time systems and characteristics of real-time systems. Prerequisite: learners should have the basic knowledge of operating systems to understand this session. Now let's see what is real-time system. A real-time system is a computer system that requires the computing results to be correctly produced within the specified deadline period. If the results are produced after the deadline period, even though they are correct, they may be of no real value and of any use. Also, in some cases, the results produced after the deadline may cause disastrous consequences. A real-time operating system, that is RTOS, is a specialized operating system designed to handle time-sensitive tasks with precise timing constraints. That is, they have to complete within the given deadline. Now, in contrast to a general purpose operating system, a real-time operating system is designed for real-time applications, and it guarantees that tasks meet strict timing requirements, which is often within microseconds. These systems are crucial in applications like industrial automation, robotics, medical devices, home appliances, embedded systems, and reservation systems. Additionally, many real-time operating systems are incorporating artificial intelligence and machine learning to handle more dynamic, adaptive, and complex systems. Now let's see the types of real-time systems. There are three types of real-time systems. That is hard real-time systems, soft real-time systems, and firm real-time systems. These systems have the most stringent requirements guaranteeing that critical tasks be completed within the given deadlines. Missing the deadline will result in some sort of catastrophe or disastrous consequences. Now, examples of all safety critical systems such as flight management systems, anti-lock brake systems, health-related embedded systems such as pacemakers. Now let's see what are the soft real-time systems. Now these systems are less restrictive, where a critical real-time task always receives the priority over other tasks, and it will retain its priority until it completes its execution. Soft real-time operating systems focus on timely execution, but missing a deadline due to some factor does not have critical consequences or disastrous consequences. Now, examples of soft real-time systems include desktop operating systems, web servers, and some office automation tools. Now, let's see the third type of real-time systems, that is firm real-time systems. Firm real-time operating systems typically require meeting deadlines, but they can tolerate occasional delays without causing any significant issues or disastrous consequences. But here, the usefulness of the output will decrease with time. So as the time increases, the usefulness of the output goes on decreasing. Now, examples of firm real-time systems include online trading systems, online auction systems, multimedia, playback, networking, and reservation systems. Now, let's move to the characteristics of real-time systems. We have four characteristics. First is a single purpose, second is small size, third one is inexpensively mass produced, and fourth is a specific timing requirements. Now let's move on to the first characteristics, that is single purpose. So unlike PCs, which support multitasking. A real-time system serves only a single purpose. That is why these systems are called as dedicated systems, or their operating systems are called as dedicated operating systems, which serve a single application. Hence, the design of real-time systems is very simple and it has less complexity. Now, many real-time systems exist in environments where physical space is limited. So, here I am discussing about the second characteristic, that is small space. For example, if we consider the home appliances such as micro ovens, dishwashers, washing machine, or consumer devices such as wristwatch, they have very small space as compared to the desktop computers. So real-time systems have to run in this limited space only. So as a result of limited physical space, most real-time systems lack both CPU processing power and amount of memory available in the PCs. Many real-time systems run on 8 or 16-bit processors and they have memory less than a megabyte. So real-time systems have less CPU processing power and less memory. Many real-time systems are implemented in home appliances and consumer devices. So devices such as digital cameras, microwaves, which are mass produced in very cost effective manner. So thus microprocessors required for these appliances for real-time systems must also be inexpensively mass produced. So this is the third characteristic, that is real-time systems are inexpensively mass produced. Now the final characteristics of a specific timing requirement, that is specific timing requirement. It is the defining characteristics of the real-time systems. Real-time systems meet timing requirements by using scheduling algorithms. The scheduling algorithms give the real-time processes the highest scheduling priority. They see to it that priorities of the highest, the processes of the highest priorities are always taken up for execution immediately. Schedulers must ensure that priorities of the real-time task do not degrade with the time. That is, the priority should be retained even after a specific time period. Minimizing the response time to events such as interrupts. Now there are two types of latencies in the real-time systems, that is interrupt latency and dispatch latency. So real-time system should always take care to see that these latencies are always kept minimal. That is, response time to events such as interrupts should be minimized, as well as the time taken to dispatch one process from execution and taking higher priority process from execution, that time should also be minimal. Now let's pause the video, think and write. Safety critical systems are categorized as hard real-time systems, soft real-time systems, firm real-time systems, or general purpose systems. Now we have already studied the types of real-time systems. So we have seen that safety critical systems are always categorized as hard real-time systems because they have stringent timing requirements. These systems have to complete their execution or the real-time task within the given deadline. If they do not produce the result within the given deadline, then it may lead to disastrous consequences or some disastrous events. So hard real-time systems are always categorized as safety critical systems. Now this is the reference book that I have used for preparing this video, that is Cryptographic and Network Security, Principles and Practice by William Stallings. Thank you for watching this video.